Hola class, it is Mr. Wicklehouse, and I'm coming at you today with something called the law of cosines. So, the law of cosines is another way to solve triangles that are not right triangles. And the law of cosines always can work so long as you have the appropriate information. So without further ado, let's look at what the law of cosines is. So the law of cosines is just a formula, and it's really the same formula over and over again, but the sides kind of mix and match and move around depending on what you're looking for. So using this formula, you can find anything that you want, whether it be an angle here or any of the sides that you need to find. So this one I use if I'm got side B and C and angle A. This one I'd use if I've got side A and C and angle B. This one I'd use if I've got side A and B and angle C, or some combination of the sides in order to find the angles. You just have to manipulate all that stuff in order to help you find what you need. Alright, so since this is going to go in and out of focus again, and I'm going to refocus it, then after I refocus it, we'll do this example. Alright, so I've got this triangle. It's like it's triangle ABC. Remember, from the last video on the law of sines, we want to draw a triangle. A, B, C. This is side A. This is side B. This is side C. Okay. So, what do I know? I know angle C is 105. Alright. I know that side B is 28. I also know side A is equal to 18. It wants me to find side C. Also notice we're talking in kilometers, so this example came from some sort of word problem where we're looking for the distance between point A and point B, which make up the vertices of our triangles. Just something to keep in mind, because the next day when we do this again, we'll be doing some word problems. Okay? Alright, so since I'm looking for C, I want to use the formula C squared equals A squared plus B squared minus 2AB times the cosine of C. So I've got A, B, and angle C, so I'm going to be able to use all that stuff, and I'm just going to plug all these things in. We got C squared equals A squared, which is 18 squared, plus B squared, which is 28 squared, minus 2 times A, which is 18, times B, which is 28, and then that's going to be multiplied by the cosine of 105 degrees. Plug all this fancy stuff in your calculator, and we'll get C squared equals 1368.89. Now we know if I'm squaring on this side, then I just take the square root to solve. So then C, I'll take the square root of this number, and I'll get 36.999 kilometers. All these problems are just plug and chug problems. The key to doing these, though, is that you need to know your formulas. If you don't know your formulas, then you're not going to be able to be successful with this. Let's do another example. Okay, so this one I'm looking for an angle. So, let's Draw our triangle. A, B, C. Side A equals 17. Side B equals 30. Side C equals 18. Make sure you get your numbers in the right spot across from the right angles, because if you don't, it'll screw everything up on you. So I'm looking for angle A. Alright. So since I'm looking for angle A, I'm going to use this one. A squared equals B squared plus C squared minus 2BC cosine of angle A. I'm going to plug everything in. 17 squared equals 18 squared plus 30 squared minus 2 times 18 times 30 times the cosine of A. Then I get 289 equals 324 plus 900 minus 1080 times the cosine of A. Then I get, combine that stuff together, I get 289 equals 1224 minus 1080 cosine A. Subtract 1224, I get negative 935 equals negative 1080. And the lights went out on me. Hold on. There we go. 1080 cosine A. I'm going to divide by negative 1080, and I get 0.866, and that's equal to cosine of A. Use my inverse trig function, so cosine to the negative 1 of 0.866, that's going to be equal to A. Well, that means that A equals 30 degrees, and we found our angle. Okay, that wasn't too bad. One more example. Solve the triangle. These are the best ones because we get to do so much fun work with this. Draw a triangle. Draw the triangle. Here we go. Drawing a triangle. Doop, doop, doop. There's our triangle. D, E, F. Label what we know. Here's E. That's 25.4. Here's F. That's 28.6. And let's see, EFD, we got D down here, that's an angle 102.9. Alright. So let's start out and find side D. Since we have angle D and these two sides, then we could say that D squared equals E squared plus F squared minus E2EF cosine of D. Plugging some stuff in, I get D squared equals 25.4 squared plus 28.6 squared minus 2 times 25.4 times 28.6 times the cosine of 102.9. Plug that into my calculator, I get D squared equals 1787.476. D squared equals that. Square root both sides. D equals 42.3 centimeters. So now I can go back up here and say D equals 42.3. Alright. Now what? Now what? What do you think? Think about it there for a second. What do we need to know, and what could we do to make our lives a little bit easier here? Got all three sides. What else do I need to solve for? I need to solve for E, and I need to solve for F. Well, now that I've got all these sides and an angle, I don't have to use the law of cosines anymore. I can go back to the law of sines to find one of my angles. And then after that, I'll be able to find my third angle just by doing subtraction from 180. So let's do the law of sines. Let's find angle E. So the sine of angle E over side E, which is 25.4, is equal to the sine of D over 42.3. Multiplying both sides by 25.4. Wait a minute, what am I thinking here? I don't write sine of the D there. Let's put the angle in there. 102.9. I went ahead and put the sides in anyway, so kind of skipped a little step there on me. But in any case, I'm going to multiply both sides by 25.4. So now I've got the sine of E equals 25.4 times the sine of 102.9 over 42.3. Inverse sine, I get E equals the inverse sine of 25.4 times the sine of 102.9 all over 42.3, which in turn ends up being E, making that equal to 35.8 degrees. So E up here is 35.8 degrees. Well, now I've got two angles, so then all I have to do to find angle F is I say that 180 minus 102.9 minus 35.8. Do the subtraction there, and I get angle F to be equal to 41.3, 41.3, and now I know everything there is to know about that triangle's sides and angles. That's pretty much it, guys. I will talk to you later. Have a fantastic day.